In our next example problem, we state the following. A sample of gas occupies a volume of 5.0 liters at a pressure of 650 torr at 24 degrees Celsius. This gas must fit into a 100.0 milliliter container that can withstand a maximum pressure of 3 atmospheres. What temperature in degrees Celsius must be maintained so the container doesn't explode? So this problem right here, there's a lot of different variables going on, and this is a direct application of the combined gas law. So the combined gas law says P1V1 over T1 is going to equal P2V2 over T2. And if we look here, we're looking for a second temperature. So we want to rearrange this equation to solve for T2, which is going to be P2V2 times T1 divided by P1 times V1. And the initial set of conditions that we're going to look at are 5.0 liters, 650 torr, and 24 degrees Celsius. Our second set of conditions are 3.0 atmospheres and 100.0 milliliters. So when we plug these pieces into the equation, we need to keep those in mind. So we're going to solve for T2, and that's going to equal P2, which is 3.0 atmospheres, times V2, which is going to be 0.1000 liters. And one of the things that we have to make sure that we do here is we need to make sure our units are going to cancel out. So we're given milliliters in one case and liters in the other case, so I'm going to be sure to convert this over to liters. That's going to be times T1, which is 24 degrees Celsius. And remember, we're going to need to add 273 here to get us to Kelvin. Then that's going to be divided by P1, which is 650 torr, times V1, which is 5.0 liters. So we can see here that our liters are going to cancel. We've gotten rid of the Celsius, and we're left with Kelvin here for a temperature, which is a unit that we want since we're solving for temperature. And now here we have 3.0 atmospheres divided by 650 torrs. So we need to convert one or the other, so why don't we convert this atmospheres over to torrs, where we know that 1 atmosphere is equal to 760 torr. So the atmosphere units canceled, and we're left with torr here in the numerator and also torr in the denominator. So they are going to cancel with each other. So when we go through and we plug all this into our calculator, our T2 is going to equal 20.84 Kelvin. And we're asked in this particular question to solve for the temperature in degrees Celsius. So in order to go from Kelvin to Celsius, we need to subtract 273. And when we do that, and we need to solve this, if we look at all our significant figures here, we have two pieces that have just two significant figures. So we need to express our answer to two significant figures, so that's going to give us negative 250 degrees Celsius. Okay, so what we did here, and remember, you have to keep a few things in mind. First of all, we have to recognize that this problem is asking us to directly apply the principles from the combined gas law. Once we recognize that, we get P1 times V1 over T1 equals P2V2 over T2, and we're going to solve, in this case, for T2. So we can rearrange the equation to solve for our second temperature. Then when we use this, you're going to find that very often you're not given the same units for everything. So you have to make sure that we cancel out those various units. When we're calculating with a temperature, we need to make sure we calculate using kelvins. Then this question asked us to express it in degrees Celsius. We figure out how many significant figures we have, and our temperature then can be expressed to negative 250 degrees Celsius, which is the temperature that must be maintained so our container will not explode.